Welcome to today's webinar. My name is Eric with Bobcat Cam. I am the demo technician with Bobcat. I wear a few hats with Bobcat. I do demonstrations of the software program. I also am part of tech support to help with any tickets with our support team, and also starting the role here with training as well, doing online training sessions and webinars just like we're doing today on specific tooling for roughing and also for finishing with certain form tools, barrel tools, and custom tools like that. We can take a look at the new tool crib and tool library in V36 and how we can utilize different types of tooling to get the best performance in terms of cycle times and also precision for the best surface finish and the best tolerance levels we can achieve here in Bobcat Cam. I'm going to take a look at the comments section, see if you guys have any comments, questions, concerns. Make sure that my mic is working properly, that we got the audio and video going here correctly. Looks like we've got a few people in the webinar here this afternoon. Welcome everyone. We're going to be looking at certain tips and tricks on precision machining in terms of performance, in terms of cycle time, and precision in terms of the best tolerance levels we can achieve. We can take a look at our simulation and verification, make sure everything is cut to size before we run it on the machine. We want to do everything one time and not have to have any guesswork involved. So let me know you guys can hear me here with the microphone I got set up here. Make sure audio is working and video. Please let me know in the chats here. And we can get started here in the next couple minutes here. We'll be looking at our first 3D model here in 3-axis milling. We'll be roughing out a 3D model like this here and looking at a finish pass down the tapered walls here to start off with a ball end mill and then finishing with a barrel mill tool, and see the difference between the barrel tool surface finish and how much easier it is to accomplish a surface finish like this, and how much more precise, you could say, how much better of a tolerance level we have with a barrel tool versus the ball end mill in terms of tooling there. All right, thanks Mike. Thanks Joe. Good to see you guys in the chats. Let me know if you guys have any other comments, questions, concerns, anything that you'd like to go over here in terms of barrel tooling, and also other tooling suggestions you'd like to see here. We're looking at a 3D model and 3-axis milling to rough out this piece of stock we can see here, and milling out this tapered surface here, the tapered wall here. And so this is 3-axis, and then we'll also be getting into 5-axis machining here, 3-axis roughing, and then 5-axis for a tool to stay normal to this curved surface with a barrel tool to give us our best surface finish possible there with a 5-axis mill. So we'll start here. We have our 3D model, and I'm going to blank everything out to start with. Basically, I'm just going to put this 3D model on a different layer here to hide it here. We can take a look at how we achieve this in CAD and then get into the CAM portion of the software program. So we started by just creating the wireframe here, just the profile of the 3D model, and then went into a basic extrude boss here to extrude this out. And we're just looking at starting off with a piece of raw stock like this in the cam tree, something like that, and roughing all of this out, and then finishing the tapered wall that we're focusing on here, starting again with a ball end mill, and taking a look at the surface finish with that, and then finishing with a barrel mill tool, and see the difference between the two there in terms of tooling. Now there's a few sections or a few options where you can set your own tools, create your own tools, and set your own parameters. Also, just setting the numbers in here. So in here, under the milling job, you can see that there is a section for milling tools. I could either double click on it or right click and go right to my tool library here. These are all of the different sections of our specific tools. We have a drill category with center drill, drill, and tapping tools here. We can go to the category for mill, where we have our end mill rough, end mill finish. In our article that we posted online, we have a great description on differences between rough and finish tools, facing tools, which are in the end mill rough category in here as well. All of these tools that I have in here are preloaded in the software program. We start with a 3-inch face mill, going all the way down to 1/32 inch end mill. And I can double click on one of these tools here to modify a tool. Go down here to add or delete a tool here as well. And here with the tool, I can type in my parameters. And I can go down here and set my own custom feeds and speeds, set my specific spindle RPM, cutting feed rate, plunge feed rate that I want to use for this tool specifically with this 1/8 inch flat end mill. Or I can check the box, use system feeds and speeds, and that will calculate everything based on the material type I'm using for my stock here. If I expand the stock selection here under the cam tree, this is our material library. And I can either double click on this. This is what I love about the newer versions here is whenever you want to edit something, you can always just double click on something now. Or you can do the old fashioned way of right clicking and editing something here. And you have your material library here, where depending on if you're machining from carbon steel, aluminum, different types of plastic, we have material types in here with specified feeds and speeds for each material type. So if we're machining from carbon steel or aluminum, we have feeds and speeds for each material type here. If you don't see your category that you want to use here, like for example, we don't have wood because there's so many variables in terms of density and water retention, things like that, I suppose, for material types for wood and the feeds and speeds for it. Now you can add a group and you could name it wood, and you could go into the category. I suppose I could just name a new group here. Wood. Now you can see that it's blank, and then we can go to the bottom here towards the middle, add material, and I can name it here. I can set what tool material it is, if it's high-speed steel, carbide, different options like that, and then my feeds and speeds for all of the different for a general feeds and speeds here. Or I can customize the feeds and speeds for each operation. If it's a rough cut, if it's a finish cut, if it's an engraving operation, drilling, we have feeds and speeds set up for each of those. So I'll just cancel out of that there. And I'll select aluminum for this one, select one of the aluminum types. Now these are general, pretty conservative feeds and speeds for each material type, and we do recommend that you contact your tooling manufacturer to make sure all of these numbers are dialed in for your specific tooling, and make sure you don't want to break any tools there, and make sure that you've got the specific feed rates that you need for your specific tools to for the most optimized cycle times there. So we'll click OK here. Now everything is calculated based on cast aluminum for my material type for my stock. I can always collapse or expand any of these options at any time. Collapse that. I can collapse the machine setup if I've got multiple machine setups in here. Now my machine setup here and my origin location here is at the top left corner of my stock. That will be my G54 location. And from the machine setup one, same workflow as any milling job. I right click on the machine setup one and go to my different milling operations where I have drilling and tapping operations. I have my 2.5 axis machining, and we're skipping down to the 3-axis milling operations here. Now with my feature 3 axis here, under my machining strategy, We have different operations here in the current operations list. We have an advanced rough, and then we have a couple Z-level finishes, one with a ball end mill, and then one with a barrel tool. Now I can always add any available operations here. I'm just going to go through the basics here. If I wanted to select an advanced Z-level, another advanced Z-level finish, add it into my current operations list, and I can always sort it by moving it up or moving it down in the list here. And if I don't want any of these operations, I can always delete it here. Then our next page, we have our posting number, set G54, work offset there for number 1. We can go to our tool for our roughing category. We're using a 1/2-inch flat end mill, and this is use system feeds and speeds. So you can see this cutting feed rate of 89 inches per minute. This is calculated based on the cast aluminum I have for my material type for my stock there. And so then I'll go to the next page. We have different cut patterns. Now we have, we could offset from the center, work our way out, start from the outside, work our way in. And we have some high-speed machining options with morph spiral and adaptive roughing. Now we have different terminology than other CAD or CAM software programs. Some other ones, each CAD and CAM software program is different in terms of terminology for their machining types. With this cut pattern, other software companies may call it dynamic machining, dynamic roughing. This one's called adaptive roughing. It's the same exact toolpath as you would be familiar with other CAM software programs, where it is a high-speed machining operation. It offers tricoidal milling, you can see here, where when it goes to the next pass, where it's doing just one directional cutting, it's cutting maybe climb mill here, or conventional milling, but here it's climb milling. So it's doing one pass. Once it gets to the edge, it will retract just a fraction of an amount there and wrap it across with rapid moves here in yellow. So it is a high-speed machining operation, keeping constant tool engagement, and setting this where you can set a pretty aggressive depth of cut. That's sort of the logic behind it, where you want an aggressive depth of cut and just sort of roughing it out with small passes there and tricoidal milling to get the job done faster. Then our next page, we have our depth of cut and step over options. Now we're stepping over 200 thou every pass, and then once we've gotten everything roughed out at that level, we're dropping down at a depth of cut of 200 thou each time. And I'll sort of leave that unchecked so we can get to that and take a look at that after we look at simulation here. Now we've got roughing. We can plunge, we can ramp, we linear ramp in, or a spiral ramp in as a helical interpolation there. If we wanted to, since this is an opening, that basically an open pocket, we could consider it. We could uncheck this box center cutting tool. So if I uncheck this box, what the software will do is it will calculate the entry to start from the side of the stock. Excuse me. We'll start from the side of the stock and enter with the side of the tool so that it doesn't plunge down and break the tool. It's going to use the side of the tool to enter into the stock if I uncheck this box center cutting tool. We have rest machining. We offer that, and we offer different linking options, a gouge check page to make sure the tool and the tool holder does not gouge into our workpiece here. If I move over this window over here to see on the left-hand side, we can see that we can add in a fixture as well. So if we have the geometry for the clamps, for the vise that we're using at the table, we can add that in as an assembly and define that as our fixture and make sure the tool avoids that as well. Make sure there's no collisions there. We have advanced feed rate options now. Those are some newer options. We could go over some of this because this is considered for the better performance, better in terms of cycle times and in terms of reducing chattering here. We have adaptive feed rates where we have radial chip thinning, and we have volume-based feed rates here. And we can set a minimum and a maximum feed rate. And for example, if I set a minimum feed rate of 10%, if I'm going at 89 inches per minute for my cutting feed rate here, you can see it'll get down to 10% of that feed rate. So as slow as 8.9 inches per minute, anywhere between that and the normal feed rate there, when it gets into, for example, into these internal corners, the software can calculate how slow the tool needs to move to keep a constant chip load, and that can reduce chattering at the machine. So that's what this adaptive feed rate option can be used for here. So a lot of great options to help with chattering, help with cycle times, and also help with the performance of the machining operations here, and helping to keep the life of the tool longer as well. Then our last page here for each milling operation is MDI. That stands for manual data input. If we wanted to add, for example, what I normally show here is raw text. If I wanted to add a comment before or after an operation, I can highlight raw text, or any of these other miscellaneous G or M codes. Highlight raw text, highlight after the operation, and then add that as a command. And you can add anything you want here. It'll just add it in as raw text, or if I select comment, if I type in anything here, it will put parentheses in between the an open parentheses and closed parentheses at the end of the text I put here. If I don't want it, I can go back to this line 1, I believe, and delete it here. The command is selected. Maybe select raw text and delete it. Yes. Then we can get to our first Z-level finish operation here. We're selecting a finish tool using a ball end mill. This is a 1/2-inch ball end mill. If I wanted to select the tool or edit it at any time, I can go to our new tool crib and tool library. So if I go to the tool crib, you can see it's revamped. It's a little different than what it was before, where we had separate windows for each tool crib and each tool library. Now it's all in one window. We've got our tool crib at the top, and we've got our tool library here at the bottom. So we can go to each category if we wanted to. We're looking at end mill rough, end mill finish. You can use a taper tool or any of these other form cutters, and we'll be getting into barrel tools in the next operation here. We're using an end mill finish so that we can select a ball end mill. Now, sometimes customers might get tripped up at the beginning with the new tool crib and tool library. It's a little bit easier once you get the hang of it. You can highlight one of these tools in the tool library, and you'll want to make sure that you either right click on the tool and you can add tools to the crib. You could also add it in with this arrow here from the tool library to the tool crib here. Or what I normally do is I drag and drop it. So I can grab one of these, maybe this 3/8 tool. I can drag it and drop it right into the tool crib here. But here I'm not selecting those 3 tools. I'm going to select the 1/2-inch ball end mill from the tool crib here, and then click OK. And then we've got our cutting feed rate and all those parameters there. We're starting from the top, working our way down with this finish pass. We're doing one directional cutting again for the finish operation, setting a constant depth of 150 thou for each depth of cut there. And I'll be only focusing on that operation in our simulation to start with. So I'm just going to hit finish. I don't want to recompute all 3 of these operations again, since everything is calculated with that, except for the entry option. I want to use a side cutting with this open pocket. So I don't want to hit compute because I don't want to compute the the 2 Z-level finishes I haven't made any changes on. I've only made changes on this advanced rough with this center cutting tool. So I'm going to hit finish. It's not going to compute anything, but it will save the changes of the entry option. And then I can expand the feature here. I can right click on the advanced rough and compute the toolpath of the advanced rough individually. And that way I'm not computing all 3 of the operations again. It's just going to compute the first one and save me a lot of time with computing there. Now you can see it's going to overflow to the sides here with the entry rather than plunging down into the stock with the roughing there. Now I want to focus just on the Z-level finish with the ball end mill here. I don't want to look at the toolpath at the moment with the Z-level finish for the barrel mill tool, just to take a look at what we can do with a finish pass with a ball end mill. So I can turn this off in simulation, and I can turn off this Z-level finish with a barrel tool for posting the G-code by clicking on this icon here of a controller with a red X. That is our post yes no option. If you right click on milling job, it's also here about halfway down, post yes no, and then also blank unblank. That's the icon with the eyeball with a slash through it, so that it's not showing any of the toolpath. If I wanted to see the toolpath again, I can show all. And then if I wanted to post any of the or allow it to post this operation, I can click on it again. And simulation as well. It also will not simulate if I hit post no on this icon. Then I will go to our simulation, click on simulation here, and while that loads, I'll go over to Vimeo, see if you guys have any questions so far there. No questions so far. Yeah, let me know in the comment section if you guys have any questions, comments, concerns, anything in regards to the simulation here. And with any of the tooling we're using today with the barrel mill tools and some other form cutters, we could take a look at creating a custom tool from scratch as well. Now, I don't like how simulation is so small. We do have a new option in V36 to open it as a separate window to make it a lot larger. So I'm going to close out a simulation here, and I can show you where that is first. We go to the top, go to File, we go to Settings, and then here on the left-hand side, we have a CAM section here of different settings. I can go here about halfway down for the simulation window. Instead of the classic embedded window from before, we do have a separate window option. And this is great for multitasking as well. If we wanted to open up simulation, we can keep it open, put it on a separate window, or put the simulation window on a separate screen, on a separate monitor. And you can see here, I can still modify the operations and still have simulation open. When I make any changes, all I have to do is refresh simulation by hitting restart, and all of the milling operations will be saved and sort of exported over to simulation to have those changes made and simulate that. So you don't have to close out of simulation, reopen it every time. Now you can make things a lot easier for you. So we'll hit run. I'm going to blank out the toolpath. And right here at the top, you can see I'm in NC mode. This will show here how many lines of code it'll take to do the roughing and the finish pass. I'm going to drop that down and select time mode. We've got length mode where it'll tell us distance traveled for the tool. And we also have time mode where it'll tell us, based on the feed rate I have set for my roughing and finish pass, it will take about 35 minutes and 34 seconds. And I'll speed it up here a little bit. Speed up the simulation there. So here's our roughing. You can see that if I slow it down, you can see that once it's done at that depth of cut, it's going to start on that side of the stock and work its way in with the side of the tool. Work its way in with the side of the tool for each pass there. So we're only using the side of the tool there. We're not plunging down in with the end mill there. All right. All right, so once we've gotten done with the roughing operation, what I can do if I want to skip the roughing, I can hit pause here. I can go to next op for my next operation here. So this is the roughing operation, it's done. And I'm going to slow it down a little bit and hit run for the finish pass. Now this is a pretty aggressive finish operation here with how much material is remaining. Now we can take a look at how to remove a lot of this material before the finish pass here once we're done with this one as well. Now here's with the ball end mill, going down, I think it was 150 thou, constant depth of cut there, all the way down. That seems like a lot still to be removed there. You can see the cusp height, they call it, or scallop height, some customers will call it. You can see the deviation between the stock and what we're trying to get down to there. So I'll close out a simulation because we're only viewing one screen here. I will double click on the roughing operation to start with, and I want to do sort of a semi-finish operation in between the roughing and the finish pass. Now you can see here under the parameters page of the advanced rough, we have this depth of cut and step over settings. Now once it's done a step over of, once we've done a depth of cut of 200 thou all the way down to the floor there, we can also add number of intermediate steps. So if I set it to 1, I'm going to hit finish and compute the roughing operation again. We'll take a look at our simulation. And once we are done going all the way down to the bottom floor there, you'll see with the number of intermediate steps, it will create. Nope, that was too fast. Once it gets down to the floor, you'll see it will come back up with an intermediate step in between each of the stair stepping, we'll call it right here. So there's all of this amount of material remaining after it gets down to the floor. See if I can speed it up and then slow it down in time. I can also move the progress bar here to where we need to get down to. It's not the next operation technically, it's still in the advanced rough. But now as, oh, there we go. Still another depth of cut there. And another depth of cut. This should be it. And then once it's done down at the floor here, it will come back and do an additional pass at each of these stair stepping here. So that you can see it now. Once it was done at the floor, it will come back and do an additional depth of cut at each level there. So that will give us less material to cover for the finish pass there. And all that added to our cycle time looks like a couple minutes. I think we were at 35 minutes and now we're at 38 minutes to add that additional stair stepping to give us a much smaller amount of material for the finish pass to clean up there. Again, we're focusing on helping with the life of the tool, making sure this finish end mill doesn't break on us, and also making sure that the cycle times are adequate there as well. So we're still at the same finish level here with the ball end mill, and we can look at how much material is remaining based on our workpiece. Couple ways of looking at that here. We can make the stock transparent here, and we can show the workpiece to see how much material is remaining that's transparent in the stock versus the workpiece that's solid here. So that's a lot of material remaining. Just by the naked eye. We could also see it even closer here, or get a better analysis by showing the stock. I'm going to hide the workpiece here. We're just looking at the stock now. And then down here at the bottom right corner, we have this green tab called Analysis. And under the Analysis tab, we have a drop down to select Deviation. If I load this deviation page, refresh it, it will load different colors here on the stock depending on how much material is remaining to get down to our workpiece. So if I zoom in closest here, I can see the green color is a cut tolerance of plus or minus 8 thou. That's cut to size. And then if I look at the tallest peaks here, the teal color is 8 thou to 26 thou remaining. So somewhere around 10 to 20 thou remaining for our cut tolerance with the ball end mill. Now let's take a look at same parameters with the Z-level finish in the ball end mill as with the barrel tool. We'll even look at it here in the feature. Using this ball end mill, we're starting from the top, going down, one directional cutting, and we have a constant depth of cut at 150 thou. Plunging down, and same parameters here with the advanced Z-level finish. I'll skip to the tool page here for the advanced Z-level finish for the barrel tool. The first barrel tool we'll be looking at will be a tangent barrel tool. We'll look at it here in our tool crib here. We've got a few different categories, standard and advanced categories. You can see here when we're defining the tool. If I modify it here, maybe we'll do it here. There we go. So if I modify the tangent tool, you can see the parameters we can set here. We can also create the custom tool for any category in our in a drawing, and we'll take a look at that after we look at the different tool paths here. So we'll look at barrel mill tangent first, and then we'll be looking at the lens barrel mill tool for the 5-axis. Because we're looking more at like a horizontal in the 5-axis. In this, we're using the side of the tool for the tangent barrel tool here. That's what it would be best utilized for. So we're using the tangent barrel tool. Same parameters, starting from the top, working our way down. Depth of cut of 150 thou, and plunging down, same parameters there. I'm going to hit finish because I haven't made any changes, just looking at everything there. I will turn off the advanced Z-level finish for the ball end mill and turn on the advanced Z-level finish for the barrel tool. We were at 38 minutes. It should be the same cycle time in simulation here. 37 minutes actually. So it'll save us time with cycle time. It will also give us a better surface finish with a different tool geometry here, different tool shape with the barrel tool. I'm just going to run through the roughing operation, and then it's got the intermediate step up of an additional intermediate step for each pass there, for each stair step there, and then you can see the barrel tool working its way down. You can see the contact with the tool is, there's a lot more contact with the tool here with this shape and with the tapering of that surface than there would be with a ball end mill. So you can see a lot of the tapering here of the tool will hit the surface a lot more. And you can just see already the surface finish is a lot better. We will go back to the analysis page here. So this analysis tab here in green, turn that on and go to the drop down for deviation and load that color. Everything is green with a plus or minus 8 thou cut tolerance. So cut to size a lot better here, and even a faster cycle time with the barrel tool as well. So faster cycle times, better surface finish, and once everything looks good, instead of posting for the ball end mill, I'm posting for the barrel tool. By going to the top and going to post, it'll generate the G code here on the right hand side for my BC3X mill machine and post processor. That's a Fanuc based post processor there. So this G code is Fanuc based, and we can right click here in the posting window, go to save as, and we can save it as an NC file or any file extension to save onto a flash drive, or send it over to the controller to run it on the machine from there. And that is about it with the 3-axis machining we're going over today with the advanced rough and the advanced D-level finish with the barrel tool versus the ball end mill. To use different tools to achieve a better, using different tools to achieve a better cycle time, and also to achieve a better surface finish on our parts here. I'll go back to the comments section, see if you guys have any comments here, comments, questions, concerns. All right. Yeah, please let me know if you guys have any questions. I can answer them throughout the online training, or if I don't get to them, if I'm stuck on something, I can always answer them at the end of the training session here. We looked at the 3-axis milling. Before we get into 5-axis milling here, for the tool to stay normal to this surface, we can take a look at creating our own custom tools in case anybody's interested in looking at that and don't have any multi-axis machines there. So I'll go to a new file here, Bobcat1, and this is how I create a specific shape and define it for my tool in the tool library. So I go to the top and go to create 2D, and I'm just going into my line function and creating some basic lines here. So I've got one line here going out 1 inch. Click OK so that I can go right from that endpoint of that line. Make some sort of form tool here. Click OK again so I can go horizontal to it. Let me go horizontal this way. And then I can go vertical. And then click OK and maybe go out this way. Or go in and then go back out. And then go back in again. So any kind of, well, that's not horizontal. Do one more line going back in. But if we have any sort of form cutter like this, we can create it. I can go up to make the cutting part of the tool, and then here I can, pretty crazy tool there. I'll go to the bottom right corner here, and rather than using a solid line for any cutting part of the tool, I can select this drop down and select a dash, any of these dash lines to define any non-cutting part of the tool. So I can go in, select, go into line, go into create 2D, go to the line function again. From that endpoint, I can go up, and that'll be my non-cutting part of the tool. Now you could also go in under create 2D, you could create arcs and create a radius at any section. You could also go in and go to fillet or chamfer and create a fillet on any of these corners, any sort of, oops, but not a dashed line. But any sort of geometry you have here, you can define it. You're just defining the profile of the tool on the right side of it, you could say. And then I can go to the top and go to cam, and I can go right to my tool library here. Like I said, there are different ways of going into the tool library. If we go to the part file here under the cam tree, there is the tool library under your milling job. If you don't have a milling job, you can go right here to cam and go to tool library. It'll open the tool library this way as well. We have our drill category. I will collapse that and then expand the mill category. Go to end mill rough. I can add a tool, and I will scroll all the way down where it creates a blank tool down at the bottom. I can double click on it, and I can name it. I will name it form cutter. And then I can type in the parameters, but if I have a specific shape, I go down all the way to the bottom here and assign tool geometry. Then it asks for my tool shape. I can just window select it all and click OK. And then I scroll up, and there is my monstrosity of a tool. There's my form cutter, and it brings in all of the information: the diameter, the flute length, corner radius, overall length of 11 inches. Awesome. And then I can set up my own feeds and speeds for the tool, or I can check the box, use system feeds and speeds, and it will calculate the feeds and speeds based on the material type I'm using in that milling job. So yeah, that is how you create any sort of tool in the tool library here. You can also do it by, if you've got the tool in this fashion here, we could say, I want to just create the tool like so. Oops, come on. Mm, 360. And it's around the y-axis. Let me try it again. Let me turn off. Let's see. So create 3D, revolve. I'm just creating the tool myself here, and then extracting the wireframe of it. You would say around the y-axis. Maybe I'll just start with this here. Here and here. Likes that chain for some reason. Here to here. Yeah, let's say I have that geometry there. I have the 3D part. I don't have the wireframe. I could always go to, I normally put it on a different layer. So I go to my layers page here. I go to my layers page here on the right-hand side. I can right-click in the layers manager and add a new layer. I can get the wireframe of it. If I didn't have the wireframe, again, I can put this on a new layer. So say if I delete all of this here, I'm kind of getting in the weeds, but if we had a 3D model, a step file from a tooling manufacturer or any company, or you have the 3D model of the tool, you can go to the top, go to Create 2D, go to Spun Profile. I can just window select the whole thing here, and then this is along the y-axis, you can see here. If I go along the y-axis and click OK, now it is active on that. When I went to Spun Profile, it was active on that CAD layer. So when I hide the layer that the solid was on, we have our profile of the tool. I know it's on the left-hand side. It might work if we define it that way. If not, you can always go to Utilities and mirror it across. So then you have the profile of the tool from a 3D model. If it's a step file, IGES file, SolidWorks part file, you could import it as a 3D model get the spun profile under Create 2D to create the wireframe of the tool. And same workflow, just going to CAM, going to the tool library, and defining the tool, assigning the tool geometry. Then from there, we'll be getting into the 5-axis toolpath with a lens type of barrel tool. I'll pause it here and see if you guys have any questions, and answer any questions that you guys may have. So check if there's. Okay, cool. All right, so let me close out of here. Yeah, let me know if you guys have any questions, comments, concerns. I can answer anything you guys have in regards to the barrel tools here, and in regards to creating a tool. If you had any questions on the spun profile or the tool creation of the profile of the tool here, to define it in our tool library. But yeah, in the meantime, I will keep going. Go to the next part file here for the lens barrel tool. Now we have, I'll just show the stock first. So the stock is this cylindrical flat shape. Is it a flat shape? What do we have for our stock? Yeah, it is flat. It's hard to see though. Let me look at it from the side here. So the cylinder is the stock is a cylindrical shape here, flat surface here, and our part has this sort of curvature to it. And if I hit S on my keyboard, S is in solid, it'll show or hide the solid part file there. So we went about creating a new milling job. Again, just going to CAM up at the top, creating a new job. Under milling job type, selecting my machine. Rather than it being a 3-axis milling machine, this time it is a 5-axis milling machine here. I believe it's head-head. So head-head is where the spindle can rotate around the A-axis and around the B-axis as well. Head table would be where if the table can rotate and the spindle can rotate on one axis each. Table is where the table can rotate. I believe that would be a platter, and then a trunnion to rotate around another axis as well. So we have a lot of different 5-axis milling machines in here. This one we're going with BC head machine, and we can go to the stock wizard, define our workpiece. So we're defining the 3D model here. And then our last page is defining the stock, whether it's rectangular, cylindrical, and I just hit calculate stock to create a cylinder around the cylindrical part file there. We could extrude it out from wireframe or select a solid model as our initial stock that we're starting with. Then our last page here is our machine setup. This is where we're defining our work offset at. Again, our G54 location. I just highlight origin, and then I can zoom in, and it creates a snap point right on top of the stock there in the center for my cylindrical stock there. And then I can hit OK. Now I'm going to delete the milling job I just created there. Just hit delete on my keyboard. Expand the milling job that I already have here. Here's where the milling machine setup is on the top of the stock there. And again, we can expand the stock, see what material type we're using here. You can always double click and change the material type to calculate the feeds and speeds for what material type we're using for our stock. If I double click, we also have the tool material type. If we're using a carbide tool, if we're using an insert cutter or high-speed steel, you can see all of those feeds and speeds will calculate differently depending on the tool material type as well. We have feeds and speeds calculated for the tool type as well there. So the first one I did was an advanced rough, and just a basic roughing operation. Again, we have our settings where if we wanted to go to adaptive roughing for our tricoidal milling, rather than a parallel, which is one directional cutting, stepping over each time, or zigzag back and forth inside of the pocket. Starting from the center and offsetting our way out, stepping over each time, which is wasted time we could be cutting. It's stepping over and air cutting. And offset in would be starting from the outside and working our way into the center of the pocket there. Then our morph spiral, start at the center, spiral its way out, so there's no stepping over there. That's a high-speed machining option, as well as adaptive roughing, where it'll spiral its way out. Once it gets to this corner, once it gets to this corner, it has to link to the next corner there. So it'll retract just a tiny fraction there, wrap it across with that yellow linking move, and then linking to each corner there. Or this is for zigzag, for going back and forth. Zig if we're doing one directional cutting. Once it gets to one side, it'll have to lift up, retract just a fraction, and then wrap it across to the next step over there. Then our next page, depth of cut and step over. And again, our number of intermediate steps, we'll take a look at 2 intermediate steps this time. So it'll do 2 additional passes in between each depth of cut to give us an even better, an even less amount of material for the finish pass to clean up there. Center cutting tool, technically we have to do that because there's no opening to this pocket here that we're pocketing out for the roughing here. We could take a look at rest machining here. Rest roughing is hypothetically if we had a previous tool, a larger tool that we used with a roughing operation to rough this out even more, with a larger tool, make things faster. We can set the previous tool diameter and corner radius. The software will calculate any areas the previous tool couldn't fit into and calculate that tool path. So essentially it's going to start right where we left off from the previous operation with that larger tool to hog everything out, and start right where we left off and avoid any air cutting that way. So that's a great way of, maybe we left off with a previous tool, a larger, maybe like a 1-inch cutter, and hogged everything out. There's just a little bit left of material left we want to use with this 1/2-inch flat end mill. We can tell the software, if I can find the page here, we can tell the software that we used a 1-inch cutter before. And if I compute that, you can see it'll just do the additional passes, which is just that. The 1-inch cutter was able to rough out everything else. The 1/2-inch cutter would just do just one additional pass that the 1-inch cutter wasn't able to rough out. So I'll turn off that rest roughing. It can be a lot more useful if I had, I know it's taking time to compute things, but say if I had a 2-inch cutter and then I'm getting down to a 1/2-inch flat end mill to do sort of a semi-finish, I'm still not really working out for the rest machining, but it can be great with more defined areas, tight corners like this example right here, where a 2-inch cutter wouldn't be able to fit into the corners here. We could use a 1/2-inch cutter to do sort of a semi-finish, you could say, or an additional roughing operation, and avoid air cutting that way. Now we'll go to linking for each step over, direct link for each step over there, and S-link, so it'll start right a little bit before each step over there to make sure there's no notch there, or a full retract to a clearance plane for each pass there. Same for between groups. Normally we retract for a safe clearance plane if there were any clamps or any sort of boss that needs to be avoided. Don't want to have a collision there. So we have a gouge check page that we went over before, our adaptive feed rate options, a couple other advanced feed rate options. If you're not able to set a rapid rate at the controller, you can convert rapid moves to feed moves. So you can essentially set a rapid rate in the G code. And linking between each group of geometry here, between each part, you can set a link feed rate, so you can speed up that process where it's linking between each group there. And then our MDI page. And I think I do have to hit compute again. Yeah, because I turned off the rest roughing. I'll hit compute again. Shouldn't take as long as the other 2 times. And so here's our rest roughing here, and we will, sorry, not rest roughing, our advanced rough here with our adaptive roughing, the high-speed machining option right here. And then our 5-axis toolpath, or I believe it starts in the center and then works its way out. Now I'm going to backplot the, make this larger for you guys to see too. If I expand any feature and go to any operation in the feature here, I can right click on the operation and go to backplot, so I can backplot the tool in the CAD geometry here rather than opening and closing simulation each time. I can see it right here following along the surface of the 3D model here. Now I'll right click on the feature and edit the feature, open that up. We are doing one of our 5-axis surface-based toolpaths, which is parallel to multiple curves. Some other great 5-axis toolpath, well, we could do this in 3, 4, or 5-axis toolpaths, each of these surface-based toolpaths. And if you have any questions, please contact us to look at any of the surface-based toolpaths. We also offer deburring in 3, 4, and 5-axis machining to break edges. Turn milling is for 4-axis, the 4-axis Pro, where we can turn down any stock. And in the 5-axis, we also offer wireframe to tilt the tool at any location, multi-axis machining for roughing out with 5-axis, swarf machining, we offer swarf machining, multi-blade for impellers, and port machining for porting with engine blocks, things like that. So we offer an array of different toolpaths in here with our surface-based toolpaths that are really great new operations there to help with multi-axis machining there. So with this one we're looking at here is parallel to multiple curves. Setting our work offset number first. Setting up our posting settings for this. We offer TCP and other settings for 5-axis machining here. That's built into the post processor. And now we get to setting our spindle RPM, cutting feed rate, plunge feed rate for the tool, and then going into the tool crib to take a look at the geometry of our lens type of barrel tool. So you can see number 1 is, you can see number 1 is the diameter overall diameter of the tool. Number 2 is the flute length, and it's going straight down until it gets to the consider it like a convex lens on the bottom of the tool here. And here it is, convex tip radius of 3/4 of an inch. So the radius on the bottom of the tool rather than on the side of the tool is curved for the tool to follow along the curved surface with the bottom of the tool rather than the side of the tool there. It also has a corner radius right on the corner there. So you've got a corner radius going out to a convex lens curvature on the bottom of the tool there. And so we'll click OK. And we're using that tool under the lens category there. And then our next page, we have our edge curves. And the edge curves is just the boundary, the outside edge of the 3D model. The drive surface is just that we're driving the toolpath from the top surface of that 3D model. We've got a lot of great options here in the surface-based toolpaths. Again, the surface-based toolpaths are included in 3-axis for 3-axis Premium, 4-axis for 4-axis Pro, and 5-axis for 5-axis Pro. And we offer different settings, like setting up an offset if we wanted to add a little material, leave a little material for the finish pass to clean up, or set a negative number to go penetrate past the surface there. We offer a trim and extend option. So if we wanted to trim back the toolpath a little bit, we can set a value here as a negative number to trim the toolpath back, or we could extend the toolpath outward a little bit further with a positive number. If so, the diameter of the tool is 1/2 inch. If we wanted to go past the surface by the radius of the tool, we can just type in 1/4 inch here to extend the toolpath a little bit past the surface. The surface is selected there. Right, and I can turn it on or turn it off at any time there. We have one directional cutting, zigzag back and forth, or spiral toolpath. Again, I'm just going to do one directional cutting. And then in some of our options here with a ball end mill, we do have settings. That's kind of funky here. Let me close that and reopen. Something weird with the surface there. Lens barrel mill tool. Also with the surface-based tool paths, we're parallel to multiple curves. We offer a maximum step over setting. We also can calculate based on the desired cusp height here as well for our surface-based toolpaths. But we'll take a look at, I think that was about it on the first page there. And then we have different tabs that's sort of our advanced UI versus the standard UI. You're sort of looking at it here. This is the advanced UI of the different tabs versus standard UI of all the different pages we select. So we tab over to our tool axis control. This one is in 5-axis, and it is where the tool will stay pointed normal to the surface. We could also have the tool 90 degrees using the side of the tool normal to the surface. Our gouge check page, linking for each step over, and we do have a roughing tab here. So if you wanted to do a roughing operation with this operation as well, I normally show depth cuts. So you can show the number of roughing passes, how far they're going to be spaced out, and a number of finish passes and how far they're going to be spaced out. So a lot of neat features in the multi-axis toolpaths, in the surface-based toolpaths that we offer here. So I will hit finish, and we can see the toolpath here. And we can go to the top and go to simulation. While that's opening up, I'll see if you guys have any questions there. Thanks, Mike. Appreciate it. Glad everyone's able to log in here to the webinar live, answer any, ask any questions that you guys have live that I can answer. Anything regarding the software program, if you have any questions, comments, concerns. And we're sort of finishing up here today with the advanced roughing here in 3-axis, and then also the multi-axis toolpath with the barrel tool to finish things up. Now again, once it gets down to the bottom, it's going to do, after the depth of cut here, it'll do 2 additional passes for each depth of cut. You can see, so it gives us a lot less material to cover with our finish toolpath there. So there's 2 intermediate steps in between each depth of cut there to clear out a lot more material before we get with the 5-axis toolpath here. If I look at it maybe in an isometric view here, we can see, well, maybe look at it from the side would be easier. If we look at it from the side, you can see the tool moving in the A and B axis to stay normal to the curved surface there. We can also take a look at our machine by selecting the drop down here under workpiece stock, looking at the machine here. See the spindle sort of dancing around there, moving in the A and B axis rotation to come down and stay normal to the curved surface of the top of the part file there. That table moving around too, kind of making me dizzy. But yeah, so the tool staying normal to the surface, moving around back and forth with the barrel tool to give us the best surface finish possible. And And based on the feed rate we have set up, you can see at the top it's only taking 19 minutes and 38 seconds. And again, we can verify that everything is cut to size by going to the bottom right corner with the green tab analysis, going to the drop down, going to deviation, and loading the different colors on the stock depending on how much material is remaining. We can see it's plus or minus 8 thou. I can turn off those colors by going to the drop down, going to none, just normal blue again. We have another verification if you guys are interested. It's the next tab over for, nope, sorry, it is the next tab over on the right. The pink tab here, measure. If I select that drop down, the first option, points here, I can click on any of these tallest peaks right here and click with my scroll wheel, and it'll go right to that point and give me an analysis of that location. It'll even show me the deviation at that location is plus or minus 9/10. So that's an even more exact number of deviation with the barrel tool that we're using there. So that's the analysis tab for deviation with the colors on the stock. That's the measure tab with points. It gives you your XYZ point location that I clicked on and the deviation here on the right hand side. Even more of a 92 10,000ths of an inch there. So, and then again, I can click on any of these locations. Maybe I'll go more towards the center here. It's going to be about the same at each location. So plus or minus 1 thou right there towards the bottom with the barrel mill tool. And yeah, so once I close out of simulation, again, I can go to the top and go to post. It will generate the G code here on the right hand side. I can make it a little larger here to see the G code. I can right click in the posting window and go to save as. I can save it as an NC file here and put it onto a flash drive, load it to the controller from there. I can also communicate with RS-232 communication by right-clicking in the posting window, going to our NC editor, and the NC editor will allow you to you can set the port number, baud rate, and all of those settings for RS-232 communication if you're still using a cable from the computer to the machine there as well. So a lot of great stuff today. We saw how to use a barrel tool and give us a better surface finish with that type of tool. We saw how to create a custom tool in Bobcat for a form cutter if you want to see that in simulation and take a look at that. And saw a lot of great verification tools in our simulation to see that everything was cut to size, and how to create an adaptive roughing operation for high-speed machining to give us the best cycle times in roughing, and also to give us the best cycle times and the best surface finish with different finish tools there. So please let me know if you guys have any comments, questions, concerns in the comments section here before I log off here. And also, please let us know what you guys are interested in looking at the webinar. It's every other Wednesday. So I'm going to look at my calendar here. Today's the 27th of March, so April 10th will be our next webinar. And if you guys have any suggestions that you'd like to see, we'd love to know what you guys want to see in the next webinar so that we're sort of on topic, and just want to keep engagement there. Thank you, Joe. I appreciate it. Let me know what you're interested in looking at next time. If you have a specific module you're interested in, anywhere from bob art, lathe, milling, laser, plasma, water jet, what have you. What type of machining are you doing so that we can tailor the webinars to exactly what you guys are interested in looking at? But I'll leave it off with that today, and thank you everyone for viewing the webinar. You can also go back to it and view it again at any time. And thank you for viewing the webinar today, and have a great day there. Take care.